Okay, let's talk about AI. It feels like it's everywhere, right? Artificial intelligence and machine learning are completely changing the game. The buzz is real, the demand for talent is just exploding, and the opportunities are, frankly, massive. So today, we're going to lay out the ultimate roadmap. The goal? To take you from zero to a job-ready AI engineer. Let's dive in.
So first things first, why is everyone so excited? Well, this number. This is a pretty good reason. That's the median salary for a machine learning engineer right here in the UK. The money is serious, and it's basically the market screaming that these skills are incredibly valuable right now.
I love this quote from NVIDIA's CEO, Jensen Huang. It just frames this whole thing perfectly. This isn't about us versus the machines. It's about empowerment. Learning this stuff is how you make sure you're the one in the driver's seat, you know? You're the one using these incredible new tools to build what comes next.
And yeah, that's the million-dollar question, isn't it? The opportunity is huge, but the path forward can look, well, really confusing. It's like a jungle of different courses, libraries, and new ideas popping up every day. The whole point of this explainer is to be your map, a clear, no-fluff guide to get you through that jungle.
Every journey starts with a first step. And for an AI engineer, that first step is building a rock-solid foundation. Seriously, this part is absolutely non-negotiable. If you skimp here, you're just setting yourself up for a world of pain later on. Get this right, and everything else becomes so much easier. So what does that foundation look like? Well, pretty much every expert agrees it boils down to these three things. You've got to master a programming language, get your head around the key math concepts, and learn your core tools, like using Git to manage your code. And when it comes to the language, it's Python. It is the undisputed king of AI. End of story. Okay, don't let a slide full of math terms scare you off. You just have to think of this as the language that machine learning speaks. Linear algebra, that's just how we handle data efficiently. Calculus, that's how a model actually learns and gets better over time. And probability and stats, that's how we figure out how good our model is and how confident we can be in its predictions.
And here's the most important part about the math. Nobody expects you to be a wizard solving complex equations on a whiteboard. The computer does all the heavy lifting. Your goal is to build an intuition, to understand how these concepts work together to let an algorithm learn. It's about the why, not about doing the calculations yourself.
All right, with that foundation in place, it is time to start building your toolbox. Because at the end of the day, AI runs on data. Data is the fuel. So you're going to need a set of really powerful tools to handle it, clean it, and understand it.
Your first tool is NumPy. Think of this as the high-performance V8 engine in your toolbox. It is built for one thing: speed. It lets you do complex math on massive amounts of data incredibly fast. And those calculations are the absolute core of pretty much every machine learning model. Now, if NumPy is your engine, then Pandas is the chassis and the steering wheel. Real-world data is, well, it's a mess. It's got missing bits, weird formatting, you name it. Pandas is what you'll use to take that chaos and wrestle it into a nice, clean, structured table, a data frame, that a model can actually make sense of.
And you can't work with what you can't see. So before you even dream of building a model, you have to explore your data. That's where Matplotlib and Seaborn come in. They are your eyes. They let you create all sorts of charts and graphs to literally see the patterns and the story hidden in your data. It's a crucial step.
Okay, foundation's laid, toolbox is packed. Now we get to the really fun part. We've arrived at the main event, mastering machine learning itself. This is where we stop preparing and start actually building models that can learn, predict, and discover.
So machine learning basically breaks down into two main styles. First, you have supervised learning. This is like being a teacher with an answer key. You give the model tons of examples where you already know the right answer, like pictures of cats labeled cat. Then there's unsupervised learning. Here, there's no answer key. You just give the model a bunch of data and tell it, go find something interesting in here, like grouping customers into different purchasing groups. So to get your hands dirty with all of this, your first stop is a library called scikit-learn. It's like the Swiss Army knife for all these classic, fundamental machine learning models. You'll want to get comfortable with these guys first.
They are the essential building blocks, and honestly, they're still incredibly powerful for solving a ton of real-world problems. Once you've mastered that classical machine learning, it's time to climb higher, to the AI Summit. This is where we get into deep learning and all the advanced stuff that's powering the incredible breakthroughs we see in the news every day, from ChatGPT to image generation.
This chart is a great way to see how all these buzzwords you hear actually fit together. So artificial intelligence is the big, broad dream. Machine learning is a specific approach to achieve that dream. Deep learning is an even more specific, powerful technique within machine learning. And generative AI, that's the cutting-edge stuff inside deep learning that's getting everyone so excited right now. And up here at the summit, these are the concepts you'll live and breathe. You have neural networks, which are the basic building blocks inspired by the brain. You have specialized versions like CNNs for vision and RNNs for sequences like text. Then you have the transformer. That's the revolutionary architecture that made things like ChatGPT possible. And you'll build all of this using one of two major toolkits, TensorFlow or PyTorch.
Which brings us to our final and maybe the most important part of the roadmap. How do you take all this amazing technical knowledge and actually turn it into a career? How do you get hired?
This quote right here tells you everything you need to know. It's a hard truth, but it's essential. A brilliant model that just sits on your laptop in a coding notebook is basically a science project. It has no value. The real value, and what gets you paid, is created when you can get that model out into the world where people and applications can actually use it.
And this is how you do it. This is often called MLOps. First, you build an API around your model. That's like giving it a phone number so other software can call it. Second, you containerize it with something like Docker. Think of this as packing your model in a suitcase with everything it needs to run anywhere. And finally, you use a cloud platform, like AWS or Google Cloud, to deploy that suitcase so it can run 24/7 and serve users all over the world.
So let's tie it all together. How do you land the job? 1. Build a portfolio of real projects, not just homework assignments. 2. Yes, you still have to grind out those data structures and algorithms for the technical interviews. 3. Try to get internships for that priceless real-world experience. And finally, and this is a big one, learn to talk about your work in terms of business value. That is what separates the candidates from the new hires.
So there you have it. The entire journey, from that first import pandas to deploying a model that can change a business. The roadmap is clear, the demand for these skills has never been higher, and the tools have never been more accessible. The only question left is, what are you going to build first? Thanks for watching.